Section 1. Electricity 101. The basics. Electricity is like water flowing through a pipe. It's a form of energy caused by the flow of electrons. These tiny particles carry a negative charge. This flow of electrons is called current. It's what makes our lights turn on and our appliances work. Voltage is like the pressure pushing the water through the pipe. It's the force that drives the electrical current. The higher the voltage, the stronger the push. We measure electrical current in amps. Resistance is like the size of the pipe. It restricts the flow of electricity. Think of it like a narrow pipe. It's harder to push the same amount of water through. Understanding these basic concepts is key to working with electricity safely and effectively. Section 2. Safety first. Respect the power. Electricity is powerful. It can be dangerous if not treated with respect. Always turn off the power at the breaker box before working on any electrical wiring or devices. Never touch bare wires. They can give you a nasty shock or even be fatal. Always use insulated tools and wear safety glasses to protect yourself from sparks and debris. If you're working in wet conditions, be extra cautious. Water is an excellent conductor of electricity, making the risk of shock even higher. Use a ground fault circuit interrupter or GFCI outlet, which can help prevent electrical shocks. Remember, safety should always be your top priority when working with electricity. Don't take any chances. If you're unsure about something, call a licensed electrician. Section 3. Wiring right connections matter. Wiring is the backbone of any electrical system. It's how we get electricity from the source to our lights, appliances, and devices. There are different types of wires for different purposes. Make sure you're using the right type of wire for the job. Using the wrong wire can be dangerous and could lead to a fire. Always use the correct color-coded wires. Black and red wires typically carry live current. White is neutral and green is ground. Securely connect wires using wire nuts or other approved connectors. Don't overload outlets or circuits. Too many devices plugged into one circuit can overheat the wires and cause a fire. When in doubt, call a licensed electrician. They can ensure your wiring is up to code and safe. Section 4. Tools of the trade essential gear. Every electrician needs the right tools for the job. These tools help us work safely and efficiently. Here are a few essential ones. Screwdrivers. Used for tightening and loosening screws on outlets, switches, and other electrical components. Pliers. Useful for gripping, bending, and cutting wires. Wire strippers. Remove the insulation from wires to make connections. Voltage tester. This essential tool checks for the presence of live voltage. Electrical tape. Insulates wire connections and provides extra protection. Fish tape. Helps run wires through walls and ceilings. Level and tape measure. Essential for accurate installation of outlets, switches, and fixtures. Remember, always use tools that are in good condition and rated for electrical work. Don't try to make do with tools that aren't designed for the job. Section 5. Electrical components. Understanding the parts. Understanding electrical components is key to understanding how electricity works in our homes. Outlets. These are the points where we plug in our devices. Switches. Control the flow of electricity to lights and appliances. Circuit breakers. Safety devices that protect circuits from overloads. Junction boxes. House wire connections and provide a safe enclosure. GFCI outlets. Protect against electrical shocks in wet locations. AFCI outlets. Help prevent fires by detecting dangerous arcing. Knowing how these components work together helps you troubleshoot problems and make informed decisions about your electrical system. Section 6. AC/DC, the current wars. Electricity comes in two forms, alternating current, AC, and direct current, DC. AC, the type of electricity that flows into our homes from the power grid. It constantly changes direction, which makes it more efficient for long-distance transmission. DC flows in one direction. Batteries produce DC power. Most electronics use DC power, which is why we have adapters to convert AC to DC. Understanding the difference between AC and DC is important for choosing the right power source for your devices and for working safely with electrical systems.